G'day guys, we've got an applications of differentiation question for you today where we've got a diagram which shows the curve with equation square root of x plus square root of y equals 3, where a and b are the intercepts of the curve, so we have a and b. A tangent is drawn to the curve at the point 1, 4, so that's this point here. So now we have to show that the equation of the tangent line is 2x plus y equals 6. Now, what we're going to do here, guys, is normally when you're given an expression which is in terms of, well, y in terms of x, we would get an equation of a tangent line which is also y in terms of x, and we would differentiate it normally. Here, what we're going to do is we're going to differentiate this explicitly to find our tangent line, but essentially it's going to be the same as finding a tangent line when we have y in terms of x. So let's get to it. The first thing I'm going to do is I'm going to make this easier to differentiate by turning those square root signs into fractional indices. So I'm going to have x to the power of 1/2 plus y to the power of 1/2 is equal to 3. So what I can do now is I'm going to implicitly differentiate this. So I'm going to differentiate this with respect to x. And so to make it easier to follow, I'll do all of the notation. So we're going to have the change with respect to x of x to the power of 1/2 plus the change with respect to x of y to the power of 1/2, which is going to be equal to the change with respect to x of 3. So when we differentiate this, guys, the first one we'll differentiate like normal. This is going to be 1/2 x to the power of -1/2. Okay, and for the derivative with respect to x of y to the power of 1/2, we're going to use the chain rule here, guys, where we're going to have to go the derivative with respect to x of y to the power of 1/2 is going to be equal to the derivative of y to the power of 1/2 with respect to y times the derivative of y with respect to x. So that's how we're going to get the derivative with respect to x of y to the power of 1/2. So to do that, what we're going to do is we're going to take the derivative with respect to y of y to the power of 1/2, which is exactly the same as this one. We're going to have 1/2 y to the power of -1/2 times by the derivative of y with respect to x. And that's going to be equal to the derivative with respect to x of 3, which is simply 0. So for the final bit of part A, what we're going to do is I'm going to factorise the left-hand side of this equation by 1/2. So what we're going to have is 1/2, and that's equal to 0. So when I take the half over the other side by multiplying by 2, it's still going to be, well, 0. So we can essentially just get rid of the half. So then what I'm going to do is I'm going to take the x to the right-hand side. So I'm going to have y to the power of -1/2 times dy dx is equal to -x to the power of -1/2, because I've just taken x from both sides. And then I'm going to take the y to the other side. So I'm going to have divide both sides by y to the power of -1/2, and I'm left with dy dx is equal to -x to the power of -1/2 over y to the power of -1/2. Now obviously we can fix this in terms of the negative indices by just taking the reciprocal of this fraction here. So that's going to be equal to negative, and rather than writing y to the power of 1/2, I'm just going to say negative square root of y over the square root of x. So now to find the gradient of that tangent line at the point P, we have the derivative now. We've got to evaluate the derivative at this particular point. Okay, so from here what I'm going to do is I'm just going to sub in my point 1, 4 into my derivative, which I've just calculated. So I'm going to have dy dx evaluated at the point 1, 4 is going to be equal to the negative square root of 4 over the square root of 1, which is equal to negative 2. Okay, so from here, like most questions which are asking us to find the equation of a tangent line, we're going to substitute this gradient into our generalized linear function, which is simply y equals mx plus c. Now we are well aware that m is the gradient of this function, so substituting in the negative 2, we're going to get y equals negative 2 x plus c. And then from here, guys, we're going to substitute in our point, because we know that this tangent has to go through the point 1, 4. We're going to substitute those values into our equation and solve for c. So we're going to have 4 is equal to negative 2 times 1 plus c. So you can see here that c is going to have to equal 6. So from there, we can write down the equation of our tangent line then is y equals negative 2x plus 6, or if we rearrange this, we can take the 2x to the left-hand side, and that is going to be equal to 2x plus y is equal to 6, which is the solution for our first part, or part A of this problem.